Hey guys, welcome to AI with AI once again. This side Asif Imnad. In the part 1 of support vector machine, in the previous video, we already discussed about what is support vector machine and how it helps us get the better accuracy and what are the advantages of support vector machine over other machine learning algorithms. If you have not watched, please watch part 1 of support vector machine video first. In this short video, I'm going to talk about more aspects of support vector machine. What do we mean by hyperplane? What do we mean by vectors? And what are the different types of support vector machine? These are also very important questions asked in the interviews. So stay tuned and watch this video till the end. Let's see what do you mean by this hyperplane. This explains it very easily. Here, this line is nothing but your hyperplane. There is a margin you can see, right? So margin is kept and this line is drawn, which is a hyperplane in 2 dimensions. Okay. Same thing. If you look at this diagram here on the right hand side, this is 3 dimension where the hyperplane looks something like this, right? So data sets are above and data sets are below. So the same 2 dimension data set is drawn in 3 dimensions. So this line will look like a hyperplane, something like this. That is why we are calling this line a classification line as hyperplane now, right? Ideally, we do not have 2 dimensions, right? I mean, we do not have only 2 columns. We have n dimensions. We have multiple columns to be considered while training our model. So our data will be definitely n dimension data. So in that scenario, we'll have to think about the hyperplane and not the line, obviously. And it is difficult for us to also imagine the data beyond 3 dimensions. But we can easily imagine the 3 dimension data. So this is how the hyperplane will actually look like, where we are keeping the margin in between, below and above, right? This is what SVM does. Okay, by now I hope you understood what is support vector machine, how it works, and what do we mean by hyperplane, what do we mean by vector, and why it is called support vector machine, and what do we mean by margin classifier. Now let me talk more about the support vector machine. I have a question for you here. Let's say I have a data something like this. Look at this data. Can you draw a line over this data? I mean, can you classify this data either by logistic regression or use any regression line or even support vector machine? Can support vector machine classify this data? Can I draw a line like this? Can this be a classifier? No, right? I need to classify green and red separately. I cannot draw a line like this to separate the data. I cannot draw a line like this to separate the data again, right? So even I cannot draw a line like this. I cannot draw a line like this. So how should I draw a line so that I get the better classifier? So by now you must have understood only drawing a line is not sufficient on the data set. This is where you will have to think of non-linear support vector machine. So if you're drawing a line, if you're drawing a hyperplane, we call this as linear support vector machine. But there are situations when you will not have the linearly separable problems, something like this. In this scenario, I cannot draw a hyperplane to divide or classify my data set. And this is where I'll have to think of non-linear support vector machine. Non-linear boundary will look something like this. So I'll have to draw a boundary something like this by which I can easily say that yes, now I can say the data sets are classified. So if anything falls under this boundary, then that is the green one. If anything falls beyond this boundary, these are nothing but the red one. But again, the question is how to do this. As I've told you, in some scenarios, you may not understand the data in 2 dimensions. You'll have to have a different eye. You'll have to think of the problem statement in different dimensions. So if I take this into 3 dimensions, let's say something like this. So this is how the data look like in 2 dimensions, right? Again, this is not linearly separable data set. So I cannot draw a line over this to separate greens from the blues. Okay. But if I draw the same data in n dimension, I mean in 3 dimensions, where I have z axis z, right? So I'm looking at, rather than y and x, I'm looking at z and x now, right? So if I look at this, if I draw this data vertically, if I rotate this data, so actually from top it looks like this, but from side it looks like this. Now can I draw the hyperplane? It's very simple, right? So from top you may see something different, from side you may see something different. So along the z axis I can linearly separate this data. Okay, so this will be my best hyperplane to divide this data, keeping the margin, considering these as my support vectors. All right, and after drawing this hyperplane, if I look at this from the top, this will be my best hyperplane, which will look like a non-linear SVM, which is eventually nothing but my non-linear SVM. How beautiful is this, right? Just to understand more, I have one more diagram here. This non-linear support vector machine is also called kernel SVM. So if you cannot classify the data linearly by drawing a line, then we take a help of kernel SVM. Kernel SVM is nothing but where the data is non-linear, where we cannot linearly separate the data, where data cannot be classified using a straight line. This is where we use kernel SVM. So again, in two dimensions, x1 and x2, this is how the data looks like, right? It is circular. I cannot draw a line. Try to draw a line. I cannot classify the data. But if I transform this, if I look at this in three dimensions, then this is how the data look like, right? So I can draw a hyperplane. So the red points go above and the blue points go below, and I can draw the hyperplane like this. And again, I transform this back. So I do the inverse transform. So my data, so the hyperplane will look something like this, and this is how I get the kernel SVM. This is how I can draw the hyperplane for non-linearly separated data. Okay, amazing. So in this video we talked about what is SVM, what is support vector machine, what do you mean by margin classifier, a maximum margin classifier, how that margin is decided, why to keep the maximum margin, what do you mean by vectors, what are your extreme data sets, and what are the different types of support vector machine, linear and non-linear. Non-linear is nothing but kernel SVM as well. Alright, so that is it for this video. I hope you understood what is support vector machine. If you keep liking these videos and comment on these videos, it will reach to more people, which will eventually motivate me to create more free videos for you guys. Okay, thanks a lot. See you again in the next video. Bye bye.